Welcome to Friday office hours. I hope you all can hear me okay. In the event that I lose audio at any time, feel free to plug that into the chat or one of my colleagues will let me know. But welcome, happy Friday, and happy Valentine's Day. My name is Sam Stewart. I'm a project manager here at the Data and Research Center, which is part of the All of Us Research program. Today's presentation will be led by myself and one of my colleagues, Jennifer Zhang, here at Vanderbilt Medical Center, who helps as well with the All of Us Research program. We have a few announcements, then I'll get into the agenda. But if you're joining us today, that means you're here to learn more about the Curated Data Repository V8 release. So one quick announcement, Baylor College of Medicine is hosting their faculty summit this May. They have opened up applications. So applications are due by February 28th. One thing I want to note about the Faculty Summit is this year, the Faculty Summit will be held in person in Houston, Texas. So I'll give everyone a moment to scan the QR code. Baylor College of Medicine has a wonderful faculty group that uses the All of Us Researcher Workbench. They are well versed in the data and how to utilize it. So if you're interested in learning more and getting trained on using the Workbench for your own research and for your training at your institution, this would be a great opportunity for you. Applications, again, are due by February 28th. I do want to note that today's session is being recorded. We will have open Q&A at the end, which will not be recorded. And then we will have this presentation posted to our user support hub within the week. During today's presentation, we're going to learn more about the different data available in the All of Us Research program. We're going to highlight any updates and new data available with version 8 of the Curated Data Repository, or CDR. We'll get some genomics updates from my colleague, Jennifer, and then we'll go into open Q&A. So we'll have probably about 10 minutes for question and answer at the end. I'm also joined by a few of my colleagues at the Data and Research Center. So in the event that I can't answer your question, they may come off mute to assist me in answering your question thoroughly. I do ask that we hold all questions until the end of our webinar today. If you do have questions, you're feel free to put them in the chat. Myself or one of my colleagues will answer them at the time or at the end of our presentation today. So if you are new to the All of Us Researcher Workbench or you are a veteran, you may have noticed that we have released a new dataset version. So version 8 is available in the Researcher Workbench at this time. And so we're going to highlight a few key updates that hopefully get you excited for using the data. So the All of Us Research program is inviting 1 million people across the United States to help build one of the most diverse data sets in history. And we welcome participants from all backgrounds, and we hope that you utilize this information in the Workbench to learn more about biology, lifestyle, and environmental health effects. With CDRv8 release, we have data from more than 633,000 participants. This is an increase from 413,000 participants that we had in version 7. As you can see here on your screen, of those, 84% of our participants have identified in a community that has been previously underrepresented in biomedical research, and 44 of them come from a racial or ethnic background in a minority group. So that's very exciting. I did want to quickly highlight our curation process just for your awareness. So this image just provides an overview of the All of Us data curation pipeline. We at the Data and Research Center receive participant data from our partners, and then that participant raw data undergoes quality control in our curation process to ensure participant privacy. That data is then harmonized and standardized to our OMOP common data model when applicable. And then that curated data is then put into the Researcher Workbench. And that's why you'll hear me say often during this presentation, CDR, our Curated Data Repository. This is the data set that you're interacting with when you're using the Research Hub, whether you're looking at snapshots or our data browser. And when you get to interacting with the data in the Researcher Workbench, the CDR is what you're interacting with. Our data are kept on a secure cloud-based platform, but you can interact with it when you have access. So with the CDR release with VH, our total participant count has increased by 53%. Here on your slide, you'll see the many different data offerings that we provide, including surveys, electronic health records, physical measurements, and wearable data. So we'll look a little bit of these in turn when we do our updates. But here on this slide is just showing you our increase by each data type. We're very, very excited as well to see our increase in our genomic data as well. One thing I want to note, if you're new to the All of Us Research program, you may be wondering, well, is that participant ID the same across the different data types? The answer is yes. So during that curation process I noted before, participant IDs remain consistent across the data types. So if you're looking at a participant that's using genomic data or measurements data, they'll be the same person ID across the two, so you can do some comparison. This is another image to show the growth increases from version 7 to version 8 of our dataset. So those pink bars you see here are version 7, while the blue bars are version 8. And as you can see, it's quite an increase. We're very excited. You can see we had substantial growth across all of our different data offerings. I do want to quickly highlight our Fitbit data did go up. We have over 59,000 participants with wearable data. I also want to note that our long reads data did also increase. We now have over 2,000 long read data in our data set currently. And of course, we have an increase in our surveys, physical measurements, and EHR data. So with the CDR release, we wanted to highlight a few of the things that we're very proud of that is now in the researcher workbench. To highlight first, we do now have inclusion of participants who self-identified as American Indian or Alaskan Native. As you can see here, we have linked some information about our extensive engagement process to allow those participant information to be available to you as researchers. We also want to note, again, the increase. Our Fitbit data has quadrupled, and now we have information from over 49,000 participants. This really does follow the success of the All of Us Research Program's WARE study, which provided Fitbit devices to participants who identified with communities that were underrepresented in biomedical research. So we do have that WARE study information now available with our Fitbit tables. Lastly, I also want to highlight again that our genomic dataset has also grown by 69%. To include the whole genome sequencing data. Jennifer will go into that a bit more, but within this data collection, I do want to highlight that we have over 1.4 billion genomic variants. So that's very, very exciting for our program. So I'm going to highlight some of the phenotypic data overview. Then Jennifer's going to highlight some of the high-level overview of our genomics data. We'll go into how to get our data access if you are new to the All of Us Research program, and then we'll take some questions. So what's new? You might want to just see it all in a bulleted way. Along with that increase in our dataset size, here's some new data offerings and structures within the CDR that we'd like to review. We do have a new life functioning survey. We do have information from the WARE data, from the WARE study. We also have program reported disease status. I'll get into that. We also have information from remote collection of physical measurements for height and weight. We also introduced a race and ethnicity subcategories. This was a very big ask for many of you. So we have that now in V8 available in the control tier. We do also have data from participants, again, self-identifying as American Indian or Alaskan Native. And we have participant-mediated EHR. So let's take a quick look at the life functioning survey. We have added the addition of a companion survey called the life functioning survey. So it was developed to collect disability response data from participants who completed the basic survey before disability measures were added to it. So I just want to note that this survey is only available to participants who were enrolled in the All of Us Research program prior to inclusion of the disability items in the basic survey. So now we have this companion survey to supplement that information. So on our user support hub, we do have a quick SQL query that shows you how to pull participants who self-reported responses for disabilities using the life functioning survey, and how you can also compare that with the specific disability questions on the basic survey. I do want to note that the life functioning survey includes a total of 6 items that were sourced from the American Community Survey that are identical to the items that are on the basic survey. So I know that was probably going to be a question, and I did want to highlight that. I'm really very excited about the information that we have for our physical measurements table. So now we have self-report physical measurements available in our measurements table. So just to give you a little bit of background, the All of Us Research program collects physical measurements from a few places, from an in-person clinical visit, through an online self-reported questionnaire, or via EHR extraction. So participants who enrolled through their participating health provider organizations can go to an in-person clinic visit. but there are some participants who live a little bit far away that may not have the opportunity to go to an in-site visit. What's wonderful about this collection method is that it provides an opportunity for participants who may not live close to that clinic site to capture their baseline physical measurements via self-report method. So all of this information will still live in the measurements table on the researcher workbench, but now you can look at the source information to see if this information was collected from an in-person visit versus self-reported through this method. We do have extensive examples in the how to work with physical measurements data featured workspace, as well as we introduced a new user support hub article about working with physical measurement data on the user support hub. I do want to highlight here, this wasn't asked, you asked and you have received. We do now have subcategories in the control tier for the V8 dataset. So participant data is collected from self-reported surveys. So in that basic survey, there's a question that notes which categories describe you, select all that apply. And some of that branching logic and subcategories are now available in the researcher workbench. So if you have controlled tier access, we have these categories and those subcategories under these specific larger branching: AIAN, Asian, Black specific, MENIA, which is Middle Eastern and North African, NHPI, which is Native Hawaiian and other Pacific Islander, White specific, and Hispanic specific. Our data science team did a wonderful job. And in our how to work with controlled tier dataset, there's extensive examples of how to query the information based on subcategories. So to see a full demographic breakdown and how it looks across the data set for these subcategories, you can visit that featured workspace. So as I mentioned before, we do now have inclusion of participants who self-identify as American Indian or Alaska Native. But to assist you and other researchers working with the data contributed by these participants, we've created a supplementary guide for researchers that is posted on our user support hub. So if you intend to work with this demographic of participants, we do highly recommend you review this guide, as well as attend our office hours on Friday, February 28th. During that office hours, our partners at the All of Us Tribal Engagement Outreach Team and our policy office will share some guidance and resources of working with this demographic. In this guide, you'll see information that provides historical context, links to relevant policies, and guidance for using demographic data along with geolocation data and some of our survey data. This is a downloadable PDF as well on our user support hub. Our wearable device data, I do want to proudly announce that we are one of the largest public data sets of Fitbit information. And I want to just really contribute to our team and efforts around the All of Us research program for this. So we, again, have over 59,000 participants who have contributed wearable device data. And about 86% of those participants who shared have self-identified as members of communities that have been underrepresented in biomedical research. The wonderful thing about Fitbit with the All of Us research program is you can explore Fitbit in a couple different ways. You can look at steps, sleep, and heart rate summary conditions. You can see how physical measurements affect health and understand responses to treatments through the wearable device information. I do want to note again that we did provide this information from our WHERE study, so you'll be able to learn more about which participants contributed via the Bring Your Own Device to our program or were participants in the WHERE study. To learn more about this, you can visit our How to Work with Wearable Device Data featured workspace, which we will be finalizing soon. And we have extensive information on our user support hub. Now, one quick note, if you're using the Fitbit data or new to it or have used it in the past, we are still using those 7 specific All of Us tables for wearable device data. That includes steps intraday, heart rate summary data, activity summary data, heart rate minute level data, sleep daily summaries, and sleep level data. We also have the device table as well if you're interested in that. I do want to highlight some information that we have on death reporting in the All of Us Researcher Workbench. So participant death information is now recorded in an electronic health record and from program reporting. So up until CDR version 8, participant death records have been solely, CDR version 7, excuse me. Participant death records were solely sourced from electronic health records and stored in the death table, which is an OMOP specific table. I do want to announce that now deceased status is available in two sources. You can get it from EHR in that death table, or you can get it sourced from a program portal collecting method, which we note as Health Pro. And that deceased information is in two new tables, the death table and then the AOU death table. So the AOU death table will have EHR and program sourced information. In that AOU death table, you can see deceased status. And so it has a little bit more information in there as well. If you're curious on where that source information was collected, you can look at the source ID in that death table to see how that source information, again, is collected. We do, again, have extensive information on how to get started with registered tier data to look at deceased participant information as well. If you have additional questions, we'd be happy to take that via our support team. Oh, also the data dictionary lists out the columns for the AOU death table. The last update I want to make about our phenotypic data is our participant-mediated EHR. So within the All of Us research program, participants have the opportunity to share their EHR or electronic health record data with us. The participants affiliated with the healthcare organizations I mentioned earlier, or the health provider organizations have that information sent to us. But now we have the opportunity for that information to be shared just slightly different. Participants also have the opportunity to have program collected through a participant portal using some API collection methods. And so what this is, kind of the bottom line to help you understand, is that the way that this data is collected is kind of helping widen the geographic representation of EHR through participant-mediated EHR. So if you are interested, now it will look the same. The electronic health record data is the same mapping and the same format. It's just the collection method is just slightly different for each, which allows more participants to provide EHR data to the All of Us research program. Again, we have a new user support hub article called Introduction to All of Us EHR Data Collection and Transformation Methods. This is going to help you understand how we at the program get information about EHR and make it into the CDR directory. And with that, I'm going to pass it on over to Jennifer, who's going to give you a high-level overview of working with genomic data in the All of Us research program.
Thank you, Sam. Next, I will walk through the genomic data available in the All of Us research workbench as part of the V8 data release. And next slide, please. And we will cover the types of genomic data, available analysis tools, and how to get started with a genomic research project. Next slide, please. As of the V8 release, over 447,000 participants have genotyping array data, and with a 42% increase compared with the last release, and over 414,000 participants with short-read whole genome sequencing data, and this is a 69% increase from the last release. More than 2,700 participants have long-read whole genome sequencing data, marking a 170% increase. We've also expanded the structural variant data to more than 97,000 samples, so which is a 752% increase. So this is now the largest joint call short-read whole genome sequencing data set in the world, and containing over 1.2 billion genetic variants, including 200 million previously unreported variants. And participants who has whole genome sequencing data also have microarray genotyping data. And similarly, those with structural variant data also have SNP indel data. And participants with long read sequencing data also have structural variant data. And next slide, please. One of the key strengths of this data set is its integration with rich phenotypic data. Over 317,000 participants with whole genome sequencing data also have electronic health records, and more than 41,600 participants with whole genome sequencing data also have Fitbit records. So enabling enabling researchers on physical activity and sleep patterns. So additional linked datasets provides further opportunities for analysis. And this comprehensive integration allows researchers to study genomic variants in the context of real-world health and lifestyle data. And next slide, please. And so with this integration of genomic data and phenotypic data in mind, let's now take a closer look at the specific types of genomic data available in the research workbench. The short-read whole genome sequencing data includes sequencing arrays in Chrome format, along with SNP indel variant data available in HALE VDS, VCF, Beijing, and Plink formats. Additionally, we provide variant annotations and auxiliary data such as genetic ancestry and other relevant metrics. So please note that the VDS contains all the variants, and the HALE matrix table, the VCF, the Beijing, and the Plink formats, we call them smaller corsets. They contain a subset of the variants in the genome. And next slide, please. So the short-read whole genome sequencing structural variant data includes joint card structural variant VCFs and sites-only structural variant files and auxiliary data such as maximal unrelated sample sets. And next slide, please. The genotyping array data includes raw IDAT files, single sample VCFs, and merged data in HALE and Plink bed formats. And next slide, please. The long read data includes sequencing arrays in BAM format, de novo assemblies in GFA and FASTA formats, and structural variant detection using SNIFOS2, PBSV, along with auxiliary data for sample labeling. And next slide, please. So I wanted to highlight some new auxiliary data for all the short-read whole genome sequencing samples, comparing with the last release. The first one is the pharmacogenomic cause, or star alleles, for the 19 drug metabolism genes. And the next one is the admixture estimation as an addition to our genetic ancestry groups for all the short-read whole genome sequencing samples. And so next slide, please. So after reviewing the available genomic data in the research workbench, let's now explore the tools provided in the research workbench to analyze and interpret this data set. We offer a variety of tools to assist users with their genomics analysis, as listed here on the screen. Common tools that can be utilized to analyze genomic data, including R and Python packages, command line tools such as GATK, and access to robust computation environments and tools such as Dataproc cluster. And then we also support two workflow engines, Nextflow and Cromwell. And finally, we offer DSUP, a command line tool that makes it easy to submit and run batch scripts in the cloud. And next slide, please. We learned about the data and the tools available in the research workbench. Let's discuss how you can get started with your own genomic research in the research workbench. So there are multiple ways to access and analyze genomic data. The first one is the genomic extraction tool. This is a point-and-click tool. It is best for analysis with a number of participants less than 5,000. So you will get the genomic data in the VCF format. And this, so the one on the right side of the screen, the variant search tool, is also a point and click tool. It helps extract participants who have the variants of interest. And you can also extract their corresponding phenotypic data. These two tools do not require an active environment to use. And if you are comfortable with coding, you can also access the data in the Jupyter notebooks. So the CDR directory documentation and the featured workspaces can help you locate the file path. And next slide, please. So here are some screenshots showing the steps on how to use the genomic extraction tool. We begin with the cohort builder, where you can define your criteria to select participants of interest and save the cohort. And next, navigate to the dataset builder, select the cohort you just created, and choose short read whole genome sequencing data. Select VCF files. After saving the dataset, proceed to analyze it. And then a window will appear displaying the extraction cost, and click on extract and continue to initiate the process. So the green running icon on the genome jumbo indicates that the extraction is in progress. Once completed, you will see a solid green dot on the genome icon and a check mark under the status column. And you can also see how long did it take to extract the data. And after extraction, a list of VCF files and their corresponding index files for the selected participants will be available in the workspace bucket, so where you perform the extraction. Additionally, during the extraction process, you have the option to export the pre-generated code for merging the VCFs once the extraction is complete. And next slide, please. The variant search is a built-in feature within the cohort and the dataset builder. To begin, we also go to the cohort builder and select SNP indel variants under the genomics section. So in the pop-up screen, search for variants of interest, and you can search by variant ID, containing the chromosome position, and the reference allele and alternative allele, or search by gene jumble or RSID. You can also apply filters based on specific criteria, such as CLINVR, significance. And once you selected the variants, save the search and the cohort. And next, we can navigate to the dataset builder and select the cohort you just created and choose the phenotypic data of interest and save the dataset and proceed to analysis. So you will be prompted to export pre-generated code to a notebook where you can select your preferred programming language, such as Python or R. And so after running the notebook, you will obtain a data frame containing participants who have the selected variants. And if you have selected the phenotypic data, the phenotypic data will also be in that data frame. And next slide, please. So as I mentioned earlier, the previous two methods are point and click tools, and they do not require an active environment. So this method and accessing genomic data using direct path does require an active environment. So here you can see an example of an active environment. So where you can customize the configuration and view the cost rate before setting it up. Once your environment is active, So the solid green dot means the environment is active. And then once your environment is active, you can create a Jupyter notebook, select your preferred programming language, as I mentioned before, R or Python. And then if you're working on the phenotypic data, you can also choose SAS. And then write your own code to retrieve genomic data path and analyze the data. On the right side of the screen is is example Python code. You can use environment variables to access path, storing all V8 genomic data, and not just V8. You can manipulate the path a little bit to get all the genomic data on the research workbench. And it including the files such as the VDS, matrix table, and others. And we can also use the gsutil command to explore the Google bucket. And we can see that both the genotyping array and the WGS whole genome sequencing data are stored there. And if you go inside to the directory, you will see the sub categories like SNP indel and structural variant and long read. And at the bottom of the screen, there is an example demonstrating how to use HAIL to load the exome HAIL matrix table and count the number of participants and the samples and list all the available fields in the matrix table. The examples I demonstrated here do not require localization of the genomic data because the tools I use, for example, the gsutil commands and the HAIL, they can read files directly from the Google bucket. However, if your tool cannot read directly from Google bucket, you will need to localize the genomic data to your current analysis environment. And alternatively, you can use our workflows such as Cromwell, Nextflow, or DSAP. I mentioned it before in the genomic tool section. So they can automatically localize the input data by default. So I think that concludes the overview of the V8 genomic data release. And thank you for your time. And I will now hand it back to Sam.
Thanks, Jennifer. I do want to note before we leave, all of this information that Jennifer mentioned is in our user support hub and our featured workspace with how to work with genomic data. So a lot of these information, including these environment variables, are readily available to you when you go to our featured workspace of the researcher workbench. So now I'll give a high-level overview about working with the data and gaining access to the data set through the researcher workbench. So here I just wanted to quickly note our data access structure here at the All of Us Research program. So the public tier is available on our research hub at researchallofus.org. It has information such as our data snapshots, our data browser, in which you can look through an interactive portal and look at different concepts to include a nice genomics browser to look at specific variants. You can also utilize our Survey Explorer to see an outline of how our surveys are structured, and even look at a research projects directory in which you can view what workspaces are currently in the researcher workbench and what other users of the workbench are doing. If you want to gain access to the researcher workbench, we have two access tiers available, the registered tier and the controlled tier. The registered tier contains our in-depth data, participant level data, which includes surveys, electronic health records, physical measurements, and wearable device data. There's specific transformations that are done on that data set, but you can still see quite a bit information. Then if you, with additional data access requirements, you can gain access to the control tier. The control tier houses our genomics data set, as well as specific health and lifestyle surveys and expanded demographic information. So if you are new to the All of Us Research program and you just want to explore, please visit our research hub at researchallofus.org. I mentioned that interactive data browser, which is seen on the right-hand side of your screen. You can look at specific concepts and domains. You can browse aggregated summary statistics to learn more about what's available in the All of Us Researcher Workbench. If you want to gain access to the All of Us Researcher Workbench, we do have on the next slide our access our access steps. So if you scan the QR code and you're interested in registering for the Researcher Workbench, you just need to confirm that your institution has a data use agreement in place or a DURA in place. If they do, then you are free to begin creating your account at that registration link. If there is no DURA in place, you can contact our support team and we can route you to our access team to give you the specific information needed to solicit a DURA for your institution. Once you gain access to the Researcher Workbench, you'll need to complete several data access requirements inside the Researcher Workbench to include verifying your identity, signing our data user code of conduct, and specific trainings for the responsible conduct of research training and our controlled tier training if it's applicable to you. If you want to stay in touch with us to learn more about our what's happening around the All of Us Research Workbench, you can subscribe to our newsletter or reach out to us at researchallofus.org. We also have an events calendar on our user support hub that I will post here in just a moment, where you can also come to future webinars such as this one, attend new user orientation, or if you're a registered user, get more information about accessing our drop-in office hours. And with that, I just want to say thank you on behalf of the Data and Research Center for being researchers of the Researcher Workbench.